Now let's do the calculation for octahedral of the octahedral complexes of the type Ma2, B2, CD. So Ma2, B2, CD, there are 4 different types of ligands. One ligand is present twice, another ligand is present twice, and the other 2 ligands are present 1 time each, and the overall coordination number is still 6. So again we calculate or we determine the possible pairs for this complex. So this is the first pair. In this A is trans to B, A is trans to C, and B is trans to D. Okay. Now none of the pairs are getting repeated, none of the trans pairs are getting repeated, none of the ligands are trans to each other, none of the same ligands are trans to each other. So this is an optically active pair. This is the next possible pair. In this, A is trans to D, A is trans to B, B is trans to C. So in this also the same ligands are not trans to each other, trans pair is not getting repeated. This is also optically active. So right now we have 2 geometrical isomers till now, both of them are optically active. Let's go to the third possible pair. So in the third possible pair, A is trans to A, B is trans to B, and C and D are trans to each other. So this is optically inactive because A is trans to A. The same ligand is trans to each other. The same ligand is trans to each other. So this is optically inactive. It will not rotate plane polarized light. It is an optically inactive pair. So now let's go to the next complex or next possible pair. So in this, A is trans to A, B is trans to C, and B is trans to D. So in this you can see that A is trans to A. The same ligand is present trans to each other. So this is also optically inactive. Now let's go to the next one. B is trans to B, A is trans to C, A is trans to D. Now see, when you are writing the possible pairs, you can only keep the ligands which are actually present. There are 2 B's present here. In the possible pairs also there are only 2 B present. 2A present here. In the possible pair also only 2 A's are present. 1 C is present, 1 D is present. So in the possible pair also 1 C is present and 1 D is present. You cannot just add ligands or subtract ligands based upon what you feel like. Whatever you see in your complex, based upon that only you have to make the possible pair. Okay, so this is the possible pair and it is optically inactive because B is trans to B. Okay, now this A is trans to B, A is trans to B, C is trans to D. So none of the same ligands are trans to each other, but a trans pair is getting repeated. This means this is also optically inactive. So these were all the possible pairs possible for Ma2B2CD complex. Now we will move to the calculations of the geometrical isomers, optical isomers, enantiomeric pairs and stereoisomers.